Okay, so hello and welcome back. So in the previous video we talked about a point dividing a line externally in the ratio m to n, and we said that if basically what we derived in the previous video was that if you had some line basically if you remember what we had if a line basically divides a line segment, suppose that for example this is A and B, and this is for example some point, I don't know, P for example, that line that divides this line internally in the ratio m to n. Then in this case, of course, there are basically two different cases that you need to consider. There is a difference between when you say basically the point P. This is all about the point P basically dividing this line segment internally. So this is about internal division. So if you are talking about internal division, then if we say that P divides AB internally in the ratio m to n, this is different from the case that this would be different from the case than if you said, for example, P divides BA internally in the ratio m to n. In that case, for example, in one of these cases, the point P would be, for example, if I don't know, for example, if m was for example, if m to 1 is for example 1 to 2 or 1 to 3 or something like that, then in one of these cases basically the situation would be something like this. And of course you see that the coordinates of the point would change. So you need to be careful about that. And the same thing applies when you say that what I mean to say is that when it comes to external division, what we derived so far was that if basically there is a line segment over here, for example, let's say that you have this line segment over here, let's call it for example A and B for example, and there is some point over here C. If the coordinates of this point is x1, y1, if the coordinates of this point is x2, y2, if the coordinates of this point was h, k, then basically what we found out, and here we said that if AC to BC, if AC to BC was equal to m to n, then the formula that we got in this case was, then the formula that we got for h and k, we said that basically h is equal to mx2 minus nx1 over m minus n, and your k is equal to my2 minus ny1 over m minus n. So that means that compared to these to the relationships that we had before we had what we had was that basically the coordinates of the point. Suppose that you have a point over here. Let's say that this is B and this is A, and suppose that, for example, this is the point, for example, P dividing this line internally in the ratio, for example, m to n. Previously what we found was that basically the coordinates of the point P are m times x2 plus n times x1 over m plus n, and m times y2 minus plus n times y1 over m plus n, and that's basically what we found over here. Now you see in this formula, what is interesting, if I take every n and substitute every n with negative n. If you go inside this formula and substitute every n with negative n, what you will get is that P is the coordinates P of P are mx2 minus nx1 over m minus n, and the y coordinate would be my2 minus ny1 over m minus n. And that is basically what we've gotten over here. So mx2 minus nx1 over m minus n, and the y coordinates is my2 minus ny1 over m minus n. So that means that when the point is dividing the line externally, you can take your n, you can take the formula that we had before for the internal division of a line, take the n and substitute it with a negative n, and you will get the division of the line externally. But of course there is still something over here that you need to pay attention to, and what that is that for example, the formula that we found over here for the external division of a line, we said that the formula was basically the coordinates of the point C were basically mx1 minus nx2 over m minus n, and then we had my1 minus ny2 over m minus n. This was the formula that we got. I'm sorry, no. This is actually something else. This is what I want to show you. But what we found was that the coordinates of the point C was mx2 minus nx1 over m minus n, and then you had my2 minus ny1 over m minus n. Okay. So this is in the case, this formula, you can use it in case the point C, point C divides AB externally in the ratio m to n. What that means is that you have this line segment over here. This is the exact situation that we had over here. You have A, you have B, for example, over here, and you have the point C over here. The coordinates of C are h comma k. The coordinates of B are x2 comma y2. The coordinates of A are x1 comma y1. And here I know that AC to basically BC, AC to BC is equal to m to n. Is equal to m to n. So it doesn't get any clearer than that. So in this situation where the point C divides the line segment AB externally in the ratio m to n, meaning that AC to BC is equal to m to n, then this is your formula. Now, what is important here? What's important here is that it would be this situation, this exact situation. You can say that basically to explain this situation to someone else, you can say that the point C divides the line segment AB externally in the ratio m to n. This is what this situation is. Okay, now suppose I said that the point C divides the line segment segment BA externally in the ratio m to n. This is different from this situation, meaning that in this situation C was on this side of this line segment AB, but over here you have your line segment AB like this, and then your point C would be over here. And in this situation, basically BC to AC is equal to m to n. Okay, is equal to m to n. And in this case, what you would get for the coordinates, the formula that you would get for the coordinates of the point C, that would be basically the coordinates of the point C would be mx1 minus nx2 over m plus n, and over here you would get basically my1 minus ny2 over n plus n. Okay, and you can of course verify this. So you need to be careful about this. And the same thing happens in the case of the internal division of a line, meaning that, for example, if you have this line segment AB over here, if you say that the point C, for example, divides the line segment AB internally in the ratio m to n, this is one thing. And if you say C divides the line segment BA internally in the ratio m to n, this will be completely different thing, meaning that in this case, for example, your line segment, I think, I'm not sure, we will have to verify this, but in one of these cases your point C is going to be, for example, suppose that, I don't know, for example, m to n is, for example, 2 to 1. Okay, suppose that m to n is 2 to 1. In one of these cases, then you will get your point C is over here. In one of these cases, what you will get is that your point C is over here. So the coordinates of the point C will completely change. And in the first case, I'm saying that it's dividing the line segment AB internally in the ratio m to n. And in the second case, I'm saying that it divides the line segment BA internally in the ratio m to n. So the ratios are the same. Or you can keep these two constant and change your ratio, meaning that you can say that the point C divides the line segment AB internally in the ratio, for example, m to n, and then instead of here saying BA, you can say for example the line segment AB, but then instead of m to n, you could say n to m, which would be a little bit confusing. So it's always better to learn these two basic things and then forget about the rest of the things, because at the end of the day, if C divides the line segment AB internally in the ratio m to n, that would be the same thing as if basically the point C divided the line segment BA in the ratio n to m. Okay, because n, and if you change n and m, and then if you change n and m and instead of AB, if you said BA, then everything would be the same, really the same. But you need to be careful about what you write or what you say, basically. So now let's do a couple of examples here and understand this concept clearly, because this concept is one of the main things in analytical geometry. It comes in 2D analytical geometry, 3D analytical geometry, and it becomes the base of your work wherever you want to go with mathematics. You cannot basically get away without understanding this concept. So let's do a couple of examples and then we will get to the rest of the things. Okay, so now let's do a couple of examples and see what we have over here. So suppose that, for example, you have this example over here. You have basically 2 points, which are A is equal to negative 2, 3. For example, you have a point A over here, which is negative 2, 3. And you have some point B, for example, which is 2, negative 1. So this point over here is right over here, negative 2, 3. This point is basically over here, 2, negative 1 is basically 2, negative 1. Now if I connect these points together, I will get this line segment in this orientation. Now I want to find the point. I want to find the point that divides AB. Now this was basically point. This point was point A. This point was point B, basically. That divides AB internally in the ratio basically 1 to 3 and 3 to 1 and 3 to 1, meaning that you're looking for actually for 2 points. You want to find the point that divides AB internally in the ratio 1 to 3 and 3 to 1. So what that means is that now if basically if I call one of the points, for example, C, and call one of the points D, for example, then the coordinates of the point that divides a line segment internally in the ratio m to n is given by basically, for example, C, the coordinates of C are basically m times x2 plus n times x1 over m plus n, and the y coordinate of the same point is m times y2 plus n times y1 over m plus n. So now if the when you say that basically you want to find the point that divides AB internally in the ratio 1 to 3, AB internally in the ratio 1 to 3. So what that means is that here basically I want to divide the line segment AB internally in the ratio 1 to 3, which means that m to n is equal to 1 to 3, meaning that m is equal to 1 and n is equal to 3. So if I use the same formula here, what I will get is that the coordinates of the line of the point C are basically the coordinates of the point C would be basically m is equal to 1 and is equal to 3. So m times, now you need to pick your x1 and x2. So since I'm considering my line segment as AB, I can take this as point 1 and this as point 2, meaning that these coordinates can become x1 and x2. These coordinates can become x2 and y2, x1 y1, x2 y2 over here. So then what that means is that I can use the same formula that I have over here and write this as basically mx2. So m is equal to 1 and x is equal to 2. So that is a 2 over here. And nx1. So n is equal to 3, x1 is equal to negative 2, 3 times negative 2 over m plus n. m plus n is equal to 4. Oops, sorry. I did do something to my pen and it kind of didn't like it. So 1 and 3, 1 plus 3 is equal to 4. The y coordinate of the same point is going to be my2 plus ny1. So m is equal to 1 and y2 is equal to negative 1. So that's a negative 1 plus ny1, which is basically negative 3 times 3 over m plus n, which is equal to 4 again. So what that means is that the coordinates of this point are going to be basically, that's negative 6 plus 2 is negative 4, negative 4 over 4, and the coordinates of this point are negative 3 minus 1 is negative 4 over negative 3 minus 1 is equal to negative 4 over 4. which is the same thing as -1 comma -1. Now -1 comma -1 would be I think I made a mistake over here. So we have mx2 plus nx1 over m plus n, and my2 plus ny1 over m plus n. Now if your m by n is equal to 1 to 3, then m is equal to 1, n is equal to 3. And I take basically x1 comma y1, I take it as -2 comma 3, and x2 y2, I take it as 2 comma -1, 2 comma -1. So let me write this again. So what I can do over here is mx2, so m is equal to 1. So the coordinates of the point C would then be mx2, which is 1 times x2, which is 2, plus nx1, so nx1 would be 3 times x1, which is equal to -2, over m plus n. m plus n is equal to 3 plus 1 is equal to 4. Y coordinate of the point is 1 times y2, which is -1, plus n times positive 3 times y1, which is equal to positive 3, which is equal to positive 3 over 4. Now this is equal to basically 2 minus 6 over 4, 2 minus 6 over 4, and over here I have -1 plus 9 over 4, which is equal to -4 over 4 comma 8 over 4. 8 over 4, which is the same thing as -1 comma 2. And -1 comma 2 would be this point over here. So what this means is that this point -1 comma 2, this point basically it basically divides AB internally in the ratio 1 to 3, meaning that this distance, if I call this distance m, and if I call this distance n, this distance over here m to this distance over here n, m to n is equal to 1 to 3. And you can see that you can of course find 3 such distances in this distance, meaning that 1, 2, and 3 you can actually find in this distance over here. So that's the meaning of the point of this point AB internally dividing basically the line segment AB in the ratio m to n, or 1 to 3. Now if I want to solve the next part of this question, then what I need to do is, the next part of this question is you want to find the point that divides AB, internally in the ratio 3 to 1. 3 to 1. What that means is that your m to n is equal to 3 to 1. That means that your m is equal to 3 and your n is equal to 1. And when I say that you want to divide the line segment AB, that means that the point A is the same thing as x1, y1, and the point B would be the same thing as x2, y2. And that means that x1, y1 would be negative 2, 3, negative 2, 3, and this point would be would be 2, negative 1. So now again you can solve this problem having this information, meaning that the coordinates of the point C would be basically again mx2, so 3 times 2 plus nx1, 1 times negative 2 over m plus n, which is equal to 4. And the next coordinate would be my2 plus ny1. So m is equal to 3 and y2 is equal to negative 1 plus ny1. So n would be 1 and y1 would be positive 3 over 4. And if you do this calculation, what you will get is basically 6 minus 2 over 4. 6 minus 2 over 4, comma, negative 3, comma, negative 3 plus 3 over 4. Negative 3 plus 3. So this is the same thing as 4 over 4, comma, 0 over 4, which is the same thing as 1, comma, 0. So 1, comma, 0 is basically this point over here. 1, comma, 0. And that is the point that divides the line segment AB internally in the ratio 3 to 1. That means that if I have basically these, meaning that this distance over here is compared to this distance, we can say that this, you can take this distance as 3 and you can take this distance as 1, which is the same thing as m to n, basically. So that's the difference between basically that's why I said it's different. It's different when you have a line segment AB. It is different when you say, for example, some point C divides AB, for example, internally in the ratio, for example, m by n, and compared to when you say, for example, some point C divides BA internally in the ratio, for example, m to n, the same ratio. In this case, for example, you would take the line segment AB. In this case, you have the line segment BA. So in this case, what you will do is that you will take x1, comma, y1 as basically x1, comma, y1 would be, for example, your point A, would be your point A over here, and B would be x2, comma, y2. In this case, you have the opposite, the opposite of that, meaning that you take your x1 comma y1 as b, and basically you take your b as x2 comma y2, for example, and over here you take x1 comma y1. So that's basically the why I said these two cases are different. And over here again, you can see that they have gotten the same answer as we got, although 4 comma negative 3. Oh, okay. So this example, like, actually you can do it in a completely different way as well. Okay. Okay, so now the example that we solved here was actually not right. We didn't do anything wrong really, but the example that we solved, the exercise that we solved, was actually something completely different, meaning that the point was supposed to be an external point and we did it for an internal point, which was actually a fortunate coincidence, because we actually did have to do that. Now let's solve the same problem the way that it was actually meant to be. So now again, consider basically 2 points. Consider these 2 points, A as basically 2 comma negative 3, 2 comma negative 3, and B as 2 comma negative 1. And you want to find the point which divides, you want to find the point which divides AB externally in the ratio basically either 3 to 1 and basically 1 to 3 and 1 to 3. So what you need to do here is that, of course, the points that you have are 2 comma negative 3, so 1, 2, and 1, 2, and 3, so that would be 1.2 comma negative 3, and 2 comma negative 1, so 2 comma, there's something wrong here, I'm sorry, this is not 2 comma negative 3. It's supposed to be 2 comma negative 2 comma 3, negative 2 comma 3. So the point is negative 2 comma 3, which is basically this point over here, negative 2 comma 3, which is point A, and there is another point 2 comma negative 1, which is this point over here, negative 2 comma negative 1. 2 comma negative 1, which is this point over here. Now I want to find the coordinates of the point which divides AB externally in the ratio 3 to 1. So externally, AB externally in the ratio in the ratio 3 to 1. So what that means is that if I have my A over here and B over here, say that this is A and B, and let's say that that point is C, then what that means is that basically then AC, if the point C is supposed to divide AB externally in the ratio 3 to 1, that means that AC to BC is going to be equal to 3 to 1. That's what it means. Or you can say that basically in the same situation, AB to BC is equal to 2 to 1. Is equal to 2 to 1 if you, for example, imagine that this point is dividing this line segment AC internally in this ratio, for example. But that's the situation that you have, and so in order to find the coordinates of this point C, what you need to do is that since you're talking about the line segment AB, you take the point A as basically -2, 3 as x1, y1, and you take the point B which has coordinates 2, -1, 2, -1, 2, -1 as x2, y2. And then what you need to do is that you need to set your ratio to m to n is equal to 3 to 1, meaning that m is equal to 3, n is equal to 1. And then use the formula for the external ratio, for the external division of a line segment, which is basically, for example, that the coordinates of the line of the point C would be basically these coordinates: m times x2 minus n times x1 minus n times x1 over m plus n, m minus n. All of your n's become negative compared to the formula that we had before, m minus n, and then the formula over here is m times y2 minus n times x1 over m minus n. And then you can apply this formula to this situation, meaning that you can write C is the same thing as is equal to basically m times x2, which is equal to 3 times x2, which is equal to 2, minus n times x1, so 1 times x1, which is equal to basically -2, over m minus n, which is 3 minus 1, and then you have m times y2. M times y2 is 3 times -1 minus n times, which is basically 1 times n x1, which is equal to -2 over m minus n, which is equal to 3 minus 1. 3 minus 1. So what that means is that your point will be basically +6 minus -2 over 3 minus 1 is equal to 2. And over here you have -3 minus -2 over 2, which is the same thing as 6 plus 2 is equal to 8 divided by 2 is equal to 8 divided by 2 is equal to 4, comma 3 plus 2 is equal to -3 plus 2 is -1, -1 half. -1 half. So it's 4 comma -1 half. So 4 comma -1 half would be 1, 2, 3, and 4. -1 half, that would be this point Negative 3 plus 2 is equal to negative 1/2. Well, there is something wrong in here. There is something wrong in here. Let me see what I have done wrong. mx2 minus nx1 divided by m minus n, my2 minus my1. Oh, sorry, I have made a mistake over here. This is y1. This is supposed to be y1. Okay, so that was a bad mistake that I made. Okay, so my2, m is equal to 3 and y2 is equal to negative 1 minus ny1, which is equal to 1 times y1, which is equal to y1 is equal to basically 3 over m minus n, which is equal to 3 minus 2, 3 minus 1. So this is equal to basically negative 3 minus 3 over 2. So this is equal to 6 plus 6 plus 2 divided by 2. So 8 divided by 2 is equal to 4, and this is 0. So you have 4, 0. my2 minus ny1 over m minus n. my2 minus ny1 over m minus n. This is negative 3 minus 3. That's negative 6 divided by 2. That's negative 6 divided by 2. That's negative 3. So that's negative 4 minus 3, which is basically this point over here. Now, assuming that, of course, this point is supposed to be along this line, so this is this point. So this is 4, negative 3, and you can see that. Now we said that this point C is supposed to divide AB. This point is B over here. Is supposed to divide B externally in the ratio 3 to 1. What that means is that this distance is supposed to be, that means that A to C to B to C is supposed to be 3 to 1. So, and what that means is that, of course, this distance from A to C is 3 times the distance between B to C, and that is the correct point that we have over here. Now, on the other hand, if you change your ratio over here from 1 to 3, let's see what we get over there. We will get another point on the other side of the line, meaning that if I'm looking for the point, find the point which divides AB externally in the ratio 1 to 3. Externally AB in the ratio, so you want to divide AB externally in the ratio 1 to 3. So what that means is that basically your m to n is equal to 1 to 3, and your points are basically these points over here. So again, you can take your x1, y1, x2, y2 as basically the same points, because we're talking about the same line segment A to B. And when I say that when you have your A and B over here in this orientation, for example, let's say this is A and this is B over here, and when I say that basically you want the point C to divide AB externally into ratio 1 to 3, what that means is that I want basically what that means is that B to C basically B to C is supposed to be 1/3 times basically A to C. Meaning that if I divide by AC over here, I get BC by AC is equal to 1 to 3. Meaning that BC to AC is equal to 1 to 3, and that's basically what happens over here. Meaning that you will get some point over here, and this point is going to be and then BC to AC is going to be 1 to 3. That's basically what this means. Now what I'm going to do is use the same formula, but the only thing that I'm going to do is just change the ratio over here, that the points remain the same. So then your point C, the coordinates of the point C are going to be equal to mx2 minus nx1. So your m is equal to 1, mx2, so 1 times 2 minus nx1. nx1 would be 3 times x1, negative 2, over m minus n, which is equal to m minus n would be 1 minus 3, and the other point would be my2, so 1 times y2, which is negative 1, minus ny1, so n is equal to 3, and y1 is equal to 1y is equal to 3, over m minus n. m minus n is equal to 1 minus 3, which is equal to 2 minus negative 6 over negative 2 over negative 2, comma negative 1 minus 9 over negative 2, which is the same thing as basically 2 plus 6 over negative 2, comma negative 10 over negative 2, which is the same thing as basically 8 over negative 2, which is negative 4, comma 10 divided by 2, which is equal to 5. So negative 4, comma 5 would be some point over here. So, and if I divide and if I connect these points over here, as you can see, if I take this point as C negative 4 comma 5, what that means is that basically BC to AC is equal to basically 3 to 1. So that means that this distance is the distance from B to C is 3 times the distance from A to C, and that's basically what this means. So you need to just, it's a very simple situation, whether it's external or internal. basically there are simply two simple equations or two simple formulas that you need to learn. So suppose that for when you have the line segment AB, and when the division is internal and the ratio is, for example, m to n, then of course the coordinates of the point C would be basically mx2 plus nx1 over m plus n, and the y coordinate of the same point would be my2 plus ny1 over m plus n. Okay, now over here what's important is that you need to understand you need to understand which one of these points to take as x1 y1 and which one of the points to take as x1 y2, meaning that you have 2 points over here, A and B. You can take this as x1 y1 and take this as x2 y2, or vice versa. Okay, now when you say that the point is dividing AB internally in the ratio m to n, you take A as x1 y1 and B as x2 y2, okay, and you take the ratio as m to n. And what that means is that for example, suppose that for example you have A and B over here. Suppose that you have your A and B over here, and m to n is, for example, 3 to 1, for example, 3 to 1. So if I take my A as x1 y1, B as x2 y2, and if the ratio is 3 to 1, that means that the point C is going to be somewhere over here, because the way that this whole thing works together is that then basically is that basically AC to BC is supposed to be equal to 3 to 1, meaning that this distance is supposed to be 3 times this distance, or the ratio of the two distances is supposed to be 3 to 1. And of course, if you say that if you want to have the coordinates of a point somewhere over here, that, for example, call it D. If you want the ratio of BD to AD to be of AD to be, for example, 3 to 1, BD to AD you want it to be to 3 to 1, then of course you do the exact same thing, the exact same formula, but then this time you have to take B as x1 y1 and you take A as x2 y2. Okay, so that's how it works, really. And of course it doesn't really make any sense to get any deeper into this, because it's actually how the algebra is working together. I cannot go inside the algebra and tell you, because, for example, in the algebra this is multiplied by this and this is added to that happens. That doesn't make any sense. You need to basically learn the situation, and then based on that situation you can pick the right formula. And of course, a formula is of course always helpful if you know how to use it. Okay, now this is about the internal division. Now when it comes to external division, it is the exact same thing, except that the definition is a little bit different. So when you say that the point C divides, for example, AB, the line segment AB, externally in the ratio m to n, what that means is that basically you have this line segments, for example AB, and this point C is external to this line segment AB, meaning that it's either somewhere over here, or it's either somewhere over here, depending on the ratio, of course. And the formula that you use for this situation is, since it's external, your ends, meaning that compared to the formula that I just wrote here, your ends become all negative. There is no other difference, meaning that the coordinates of the point C you can write as mx2 minus nx1 over m minus n, and over here you have my2 minus ny1 over m minus n, and then if you, for example, if somebody asked you, for example, the point C divides the line segment AB externally in the ratio m to n, so you take your m and n as instructed, and then since they told you that it divides the line segment AB externally, A becomes your x1 y1, and B becomes your x2 y2. And then you will get some point outside, some point on the other side of B, basically. And if somebody told you that the line C, that the point C divides, for example, AB divides BA externally in the ratio m to n, then you will take your point over here, and then you'll have to do the exact opposite of this situation, meaning that you take your A as x2 y2 and B as x1 y1. That's I mean, very simple, but of course you have to work with this a little bit and see the different cases, do a couple of graphs and see how your points are transported along the plane while you do different things, so that you get the hang of it. Moreover, you do need to derive the formula on your own to understand the process of the derivation of the formula. That's also important. So that is that. Well, we do have a bunch of examples over here, and we can do one more of them and see how number 2, for example, works. Let's do one more of these examples, and then we will, let's see what happens. I think. And the next example I think I'm going to do in the next video. So I'll see you in the next video.